Our first video for Chapter 3, we're going to cover sections 3.1, 3.2, and 3.3. So you can go ahead and put today's date just in that first spot right there. Alright, so we are going to work on inequalities in Chapter 3. That's your greater thans, your less thans, and here's a nice little helpful chart that you can put in your notes. So go ahead and push pause and write all of that in. After you do have this written in your notes, there's a couple I want to point out. The trickiest ones are going to be these four down here on the bottom. You can see that at most, a lot of students want to say that that should be a greater than, but it actually falls under the less than or equal to. So at most means that's the most that something can be, so it can only be that amount or lower, so that's why it's a less than or equal to. Also, no more than, when we see more than, we tend to want to say it's a greater than, but it's got that word no in front, so that means it can't be greater than, so it's going to be less than or equal to. Over here, at least, that's saying it's the least that something could be. It can't be any smaller, so that falls under a greater than or equal to. And then no less than with that word no in front means that we cannot be less than something. So that's why that is a greater than or equal to also. So look out for those four. Those are the trickiest ones. I think the other ones are pretty straightforward. All right, so graphing inequalities. You notice this first example, we have x is greater than negative 2. So when you guys do your graphs, here's all I need you to do. We're going to draw a number line. I want that negative 2 in the middle. And I do want a number on each side. So remember, on the negative side of our number line, the negative 1 would be on the right, the negative 3 would be on the left. And then you decide, should it be an open or closed circle based on the inequality. So any greater than, without that or equal to bar, a greater than is going to be an open circle. And then which way are we going to shade that open circle? Maybe I'll make that a little big. Oop. Open circle, and then we're going to shade all the values that are greater than negative 2. So greater than negative 2 is going to be heading to the right on a number line. So what we're saying is that x could be any number that's greater than negative 2, but it does not include the negative 2. Because it does not include negative 2, we do an open circle, and then x could be any number that's shaded, which is going to be any number on the right side heading toward the bigger numbers. Alright, so this next example, 1 is greater than or equal to m. If you notice, this m is on the right side of our inequality. The easiest thing to do is going to be to just flip this entire thing around and rewrite it so the variable is on the left. So we're going to say m is, we have to flip the inequality also, less than or equal to 1, and that's going to be a lot easier for us to graph. Students tend to graph these incorrectly if they don't put the variable on the left side first. So on number line, we put 1 in the middle, and then I want the numbers on each side, so you have 0, 1, and 2. And then we want an open or closed circle. Well, this one is less than or equal to, so that or equal to will get a closed circle. And then you want to shade all the numbers that are smaller than 1. And numbers smaller than 1 on a number line are all the numbers on the left side, so we'll shade to the left. Alright, when you write an inequality from a number line or from a graph like this, my best advice for you is to put your answers are going to look a lot like what we graphed on the last slide. So you're going to have a variable, you're going to have a number, and you're going to have the inequality in between. Please, please, please put the variable on the left side and the number wherever the circle is, so that negative 2 on the right side. When students put the variable on the right side, if they have this switched right here, they have those two switched, they tend to get this wrong. So just variable on the left, number on the right. And then we have a couple things to think about. This is a closed circle. So closed circle, your options are less than or equal to or greater than or equal to. So because we're shading to the right, would that be a less than or a greater than? And that one is a greater than. So greater than or equal to. And that's how you write the inequality for that graph. Alright, second one here, our circle is at 0, so we put the variable on the left, the 0 on the right, And then this is an open circle, so this could be a less than or a greater than depending on the shading. If we notice the shading is heading to the left, so that's going to be a less than, so we're going to say x is less than 0. Alright, moving on to 3.2. When you solve inequalities with addition and subtraction, this takes us back to our one-step equations, only instead of an equation, now you're going to have an inequality. Instead of an equal sign, you'll have an inequality. You still will solve them the same way, so go to where the x is. You can see that we're adding a 5, so the opposite of adding 5 is subtracting 5 from both sides. Your 5's cancel, leaving you with x is greater than a -3 and a -5 give us -8. And then this one did say graph the solution, so I'll go ahead and graph. So this is our solution. We'll graph it on a number line. Remember that -8 goes in the middle. -7 on the right and -9 on the right. Should this be an open or closed circle? It's just a greater than without that or equal to, so that is an open circle. And then x is greater than -8, so we are going to shade to the right, to the greater than side. Translating words. So on this translating words, it doesn't say to solve, we just want to write the inequality. So we have 4 less than a number. So there's that less than. Remember the trick from our last unit where anytime we saw less than, we wanted to switch the order that it was written. So we're going to say n minus 4, because less than is subtraction. Now is more than, so that's more of a straightforward, is more than is going to be greater than. And if you're not sure which inequality this should be, just go ahead and look back at that chart at the beginning of your notes, and then -4. So we translate it into that statement. Next one, the sum. Sum is addition of a number and 3, so we can say n plus 3 is at most. Now, at most, go ahead and look at your chart. The more you review those, we'll start to memorize. At most means that's the most something can be, so it can't be more than, so we're going to say less than or equal to, and then 2. All right, here's our last slide, and I have a couple or a few examples written in because I forgot to type those in. So here's something really important you have to have written in your notes. Well, you want to have all this written in your notes, but now we're solving inequalities with multiplication and division. So there's something that might happen, and we have to try really hard to remember because it's easy to forget. When you divide or multiply both sides of your inequality by a negative number, you have to flip the inequality. So let me talk through a couple of these, or a few of these examples. So we have 4x is greater than 12. To get x alone, you would divide by 4. So do you see how I'm dividing by a positive number? I don't have to worry about flipping anything. So x is just going to be greater than 3. Now this next example, -3x is less than or equal to 18. To solve for x, you would divide by the -3. Now, we're dividing both sides by a negative number, so when we rewrite this, this is one where your inequality will flip. X is going to become greater than or equal to -6. This last one, x divided by -5, the opposite of dividing by -5 is multiplying by -5 on both sides. That cancels, but we did just multiply both sides by a negative number. That will flip the inequality also. So x is less than -10. So this deserves big stars in your notes. It's really easy to do. You know, we just quickly flip the inequality, but that also makes it really easy to forget. So you want to be very careful when you're multiplying or dividing both sides by a negative number to flip that inequality.